all about trusted hardware, but more importantly, how do we know that a particular hardware is trusted? As Xiaofei said earlier, the first version of SGX, the Intel SGX chip in 2015, V1, had a whole bunch of bugs. I was reading the papers then, and I was like, and I think it was one of these cases where the product was not yet ready to ship, but Intel had to announce it, and so they announced it. But anyway, so I don't have, you guys can just do your own Google on all the bad news. This is a more interesting slide for our discussion. So the number of devices being shipped today is growing enormously. So, and I put IoT in there. I looked at IoT numbers because these devices are connected to each other via Wi-Fi, via Bluetooth, and so on. And when I mean devices, I mean things like that. So this building is packed full of sensors that are part of the HVAC system. It's right there, your fire alarm. Your plants, whether it's oil rigs, oil processing facilities, I don't even mention nuclear, you saw the picture of the nuclear reactor, all the way to your home and your vehicles are full of sensors, full of these IoT devices. And so the general question is that for any piece of hardware, how do we know the provenance information of the components that make up the hardware? And so we can start by simple hardware such as your home Wi-Fi router, or we can go all the way up. The same principles, the same need for provenance information is also true for chips that are very complex, such as the SGX chips and the TEE, this Trusted Execution Environment. This is the confidential computing services that are now launching. Azure has one, Google has one, and there are multiple hardware providers now doing the same thing. So why is this of concern? Because increasingly in the cybersecurity space, people are selling tools that claim to be using AI capabilities. So the basic idea is in your enterprise organization, you have the security admin running a bunch of tools that's taking data from the Wi-Fi access points. So there's this thing in the access point, and the router is called the MIBs, the Management Information Base, collects information such as how many people are connecting to it, duration of the connection, the type of protocol, the type of keys you're using, and so on. So this is valuable information, and this is just being fed into the AI tools to advise the IT guy to do this or to do that. And my question to that is, well, how do you know that the device is reporting the correct data, right? How do you know that your devices in your environment have not been compromised, not compromised to kill it or to change it, but to actually skew data? So this is very important when you have plants that require temperature sensors. You need a sensor that says, well, it's 20 degrees Celsius, and the firmware has been hacked. Now it's reporting 5 degrees higher or lower, even worse, lower, because now it's actually 29 degrees when in fact it's reporting 24 degrees Celsius. So zero trust. So you hear the word zero trust quite a bit, and I encourage you to read NIST. So the National Institute of Standards in the United States published a NIST 800-207 document. Just Google NIST Zero Trust. So the idea of zero trust is that the previous paradigm of thinking that an enterprise environment has firewalls, that you're safe behind walls, it's no longer true. So I like to think of your enterprise as a golf course. Suddenly you're playing golf in a wide open golf course, and you can be attacked at any time. So that's number one. Number two, the other important point is that you have to assume that the attacker is already inside your organization. You assume that. Do not assume the opposite. Assume that there is malware somewhere in your system, whether it's in an employee laptop or whether it's in one of the devices in your organization, but it's there and it's ready to jump at at any moment. So I liken it to see this, there's two worlds happening. There's the top visible world, which is all the enterprise stuff we used to look at, employee data, transaction data, all the stuff we do today, AI is up here. And there's this whole thing that I say is underwater, because this is all the suppliers and their supply chains and how they contribute to the trustworthiness. Right? So a simple example that I was very involved with is this TPM chip, Trusted Platform Module chip, that it's a tamper-resistant chip. It has a number of keys, and depending on who your manufacturer is, whether it's Intel, Infineon, or STMicro, the way they create the keys inside the chip is different. Some are injected, some are not. If it's injected, it means the key pair was generated on a PC next to the, construction chain, and then the private key is actually written into the memory of this chip, right? So different practices will create different degrees of trust. And this is nowhere recorded. It's not documented anywhere, right? And this is one of the big issues that the industry is facing today. So in a sense, we're living in one enterprise or one system, one organization, and you have two ecosystems. One is visible. You think you live in the top ecosystem, but there's a whole thing that's very messy down there. The supply chain of goods, of electronics, is not a linear. When you see supply chain, you think it's a linear thing. A sends to B, B sends to C, and finally it gets into a container from Shanghai terminal. It lands at Los Angeles, so whatever the terminal is here. No, in hardware, in electronic hardware, it is very complex. So a particular chipset could be used for PC computers, it could be used for cars, it could be used for something else. It's a complex network. So how do we capture this? How do we document this in such a way that this becomes truthful data that in fact could be used by the AI system in the enterprise? So that the AI system can say, well, I want to assign a trust score, a risk score to all my devices. If I was enterprise IT guy, I have 4,000 servers, that's 4,000 boxes. I have 400 access points, that's 400 different devices. For each one, I need a risk score. In fact, I need a bar from red to green, and then I can say, well, okay, turn off all the red ones because those are just too risky. This doesn't exist today because this type of data doesn't exist yet. And so this is one of the reasons why I was initially was very involved in the design of these chips like SGX and so on, and then realized that really half the story is all this supply chain information that no one is capturing. I helped create a kind of not even a working group, it was a discussion group of the members of the US, it's called the Global Semiconductor Alliance, and it only ran for like 14 months because the members suddenly realized that to capture all this information required a complete overhaul of the way they manage their own production, and everybody was kind of scared. Okay, we don't want to change. And I'll talk about the recent executive order from the White House, by the Biden White House, that will probably force these manufacturers to change the way they handle data about their production. So I thought, well, what would be a good use case? Because when your enterprise gets hacked, and discounting CrowdStrike, because that's your airline. Anybody here got affected by the airline disruption with CrowdStrike? Anybody got stranded at the airport? No, see, it's not personal. You see what I mean? It's, if you can't access your email server, it's not personal. So what's something personal? So let's do cybersecurity for vehicles. And I encourage you to look at the famous Jeep hack of 2016. So in this case, there's a Jeep Wrangler driving on a freeway, and another car just drove next to it, and it was connecting to the Bluetooth of the Jeep, and the other car was managed to hack into the Jeep, took control of the Jeep, and made it stop, right? Because they're friends. It could have been worse. It could have been put the Jeep into a crash, right? So this is a personal thing, and it will affect you. And if you have an ordinary non-EV vehicle, your ordinary, not even maybe even a hybrid. These vehicles have at least 30, if not 40, microcomputers on board, right? There's one for the power steering, there's one for the transmission, for the guys who know car engineering, there's one for your brake system, there's one for the fuel injection carburetor, and that's what it's for. I'm missing another, audio. It's packed with these microcomputers. And so this represents really like an enterprise network in a vehicle, right? These are attack points. These are things that need to be updated. And so we thought, well, we need some kind of a way to sort out this mess, because we need a framework that would work for EV vehicles, for enterprise IT security, for plant security, and so on and so on. And this is what a group of us came up with. This is from the Trusted Computing Group. And this is a framework that you could think, it applies to many things. So this is your device down here. So this could be your fire alarm that has firmware. Periodically, it needs to provide signed evidence about its state. And this is where it gets complicated, because when I say state, there's two types. There's static state, which is what type of software is needed for that. It's loaded. And then more difficultly, there's this thing called runtime state. So once a computer runs, the memory configuration changes, right? So there's a number of bounded, a computer piece of software can only run in this certain part of memory. How do you know it's doing so? So this is an open problem for a lot of the hardware developers today. It's easy to do hardware today that has memory management and so on, but to have one that is able to provide evidence of the dynamic state of the memory and the CPU, that's a difficult one. Another difficult one, which I referred to earlier, is the manufacturers. So if you take your PC computer, you guys got a PC computer over there, it's got at least 10,000 pieces of hardware in there, and many of them are coming from different manufacturers. Some come from one manufacturer, right? And so the question is, well, each one of those manufacturers now need to stand behind their product. I have a little chipset, graphics chip to do graphics for the screen. Here's my firmware. Is my responsibility finished at this point? And the answer is no, right? Because I'm selling this to a PC OEM. The PC OEM, like HP or Dell, needs to put this together. Right? So this is how the industry works out. They put this together. The famous Dell thing will do it in 6 hours, and then your PC arrives at home, the next day, right? So that model needs to change, because there's no accounting on which pieces of hardware has gone into the PC, who's the manufacturer, what was the firmware, did the manufacturer digitally sign the firmware? Today the answer is no. Very few companies, other than the big providers like Microsoft, digitally sign their code before they ship it. So this is the generic model, and it's called endorsers, and because essentially you're asking the manufacturers to stand behind the product. If you make a graphics card, you have to be able to say, well, this firmware is correct for this version of the graphics card. It does not have, I guarantee it doesn't have any malware in there. Right, so this also gets complicated. Further, this is all bad news. If you are constructing something even bigger like a router, you have software developers in your dev team that's running this code, operating system, and so on for the router. Sometimes engineers get too lazy. I'm an engineer, so I know sometimes we get too lazy, and we pull down code. Oh, I need a library to do GCD computation. I'm too lazy to write one. You know what? I'm just going to Google this or ask ChatGPT to give me one. And voila, there's a library there in whatever C or C++. I'll pull it down and I put it into my code base. And I'll probably just do a quick look without read it. It looks good, looks okay. That is a bad practice that needs to stop. And so internally within a lot of companies, there needs to be a change in the way software development tracks the components and modules. And this I'll talk about later on. It's called the software bill of materials. And this is one of the items demanded from the executive order, the White House Executive Order 2021. So this is what it kind of would look like, and I'm using the vehicle again. There's a whole bunch of these ECUs, and it's going to have it's got its attester unit, it's going to have a composite attester, and then the whole thing is collated into an evidence that's signed by this guy, has to have a key in there, and some automotive verification center. It could be the HQ of Honda or whatever the vehicle is. It could be a third party. It's going to verify through all this pile of evidence and compare each one with the endorsements, right? Now, so far we've just done the static. Okay, I told you before, the dynamic, the memory management, memory structure thing is very difficult to perform, and people are still doing that. And so then the automotive quality assurance people say, okay, this car is correct per specification from version a year ago, great, it's safe. Now you can update it. You can do a remote update. So the model that people are moving on to is that for particularly new vehicles, it's going to be loaded with 5G or 5.5G communications. You're going to do a firmware update over the internet or over the 5G. Right? And it should work, right? And if you cringe back there, you can continue cringing because this is going to be a problem, right? So and then you say, well, okay, now these sensors in the car can begin depositing the measurements, the data, sensor data into some repository. It could be used for, your local LLM or training, or this could be a training engine that's up in the cloud somewhere that's reading from all the vehicles, right? So this is open to different models. So this is kind of the idea, very simple, that before you do a remote update to a car, you really need to make sure it gives you this evidence. And this thing is going to chug through all the evidence, and if it's missing any of the endorsements, it's going to pull, okay, look at my hand, it's going to pull from the vendors the evidence. In reality, none of the vendors have this up there. This is the big problem, is there's no mechanism today to allow groups of hardware providers in a particular vertical to make available endorsements in a standard data structure in endpoint on the network that's uniform, so you can always pull. And there's not even an identification mechanism that's standard per component. There's no like 16-digit or 32-digit number for every component, right? So this is part of the standardization effort that I'm involved with. So once you check the car, then you can do the firmware update. So the car is just an example, by the way. This is you can replace this with your enterprise. So this begs the question, and the language used today is called supply chain transparency. You see this a lot being mentioned. And so in May 2021, soon after the White House produced an executive order on cybersecurity, this thing came out. It's like, okay, gee, these NIST guys and the NSA guys are very coordinated. You think, what's happening? So these are a whole bunch of demands. And you think, well, who is this addressed to? Right? So the model that happens in the United States is that the federal government is a big buyer of PC equipment and hardware. Right? I don't mean DOD necessarily. Washington, D.C., full of, offices, they all use PCs, right? So they have a lot of buying power. And so this is where the government says to the suppliers in the United States, you need to have XYZ features, otherwise I'm not going to buy your PCs. Simple as that. And this is the only thing that will make the PC companies jump, right? So if you're working for a PC company in the United States, federal sales are like top guys. Sales guys are always the top guys. The treasured, the CEO's babies are always the sales guys because they bring the revenue, right? And so when the sales guys go back to HQ and say, hey, the guys in the White House and government are now demanding A, B, C, D, typically the CEO will listen to these guys. And so what this thing is asking is that for all the components that go into electronic devices, into cars, you need now to provide the endorsements. You need a way to standardize the way they're updated. You need to provide a structure of how these things fit together. And it's called the software bill of materials. Now, unlike your traditional bill of materials, which is, bill of materials when you build a house, the construction guy will say, here's the bill of materials. You need 2,000 tons of concrete. You need so many piping. This is your expenditure, and there's a number. That's not what I'm talking about. This is a tree structure of all the pieces and the sub-pieces, all the firmware and the piece of this software that make up the platform. So it's incredibly complex. Right? Even the NIST guys are saying this is a multi-year effort that's going to take another 5 years to 10 years, right? And so, probably read that as well. So the idea would be that back to our developer, if a developer is writing a piece of code and is going to incorporate code into the build, remember a typical software dev team, 100 people, 500 people, they're going to pull all this stuff into GitHub, they're going to compile it. When you compile this, you need to keep track of what libraries you use, which pieces of code you wrote, which pieces of code your peers wrote, and which pieces of code you actually imported from outside the dev environment. So work in progress. What am I doing in this space? So a number of things. I'm working with the Trust Computing Group trying to standardize some of these endorsement structures that the tree thing I said before, right? Because to the hardware manufacturers, this is as confusing even to me, because this is quite a complex thing. The PC computer industry has a history of just doing things, I don't want to say ad hoc, but they've always been driven by, deadlines, right? PC, you have to deliver the next model by Christmas, right? So people panic, freak out. They don't do security, quality control. I have to drop ship this by 10th of December. It has to be in Best Buy in the United States by 15th of December. That's the kind of pressure, and that kind of model needs to change. The other question I asked is, well, some of these small chipset vendors, they may go out of business, right? It's quite possible. They get acquired. This first case, how do you account for the digital signing certificates of vendors who don't exist anymore? Who's going to keep this, right? So you bought your car, and the chipset vendor in Taiwan goes out of business. Who's going to update the firmware for that particular chipset in your car? Is it the car manufacturer? Who is the car manufacturer? Is probably going to say no, because it's just more work for them. They're trying to reduce work, right? And so is there a way to record this somewhere, such as on a ledger somewhere, on a blockchain somewhere, at least the hash of it, so that even when the business is gone, this information is still available on the open internet. The second thing is, what happens if a product is end of life? So here's a chipset. I'm still in business, but I no longer support this. It's an easier case because the vendor can still, put it up on one of the servers. The old, end of life product, still there, firmware still there, signature still there. You can still verify it. Thirdly, if a vendor uses a signing certificate, like an X509 digital certificate, to digitally sign the files, those things need to be replaced, particularly usually annually. Public key pair, good practice every year, regardless if it's even elliptic curve or ECD, the standard ECDS, replace it every year. And so the question is, how do you archive the old keys and the old certificates? Where do you put it, right? So this is the classic problems that's still with us. And I think that is the end of my presentation.
Dr. Hardjono, so we have a few minutes for questions.
Oh, yes, the guy who cringed in the back, he's not going to buy a Tesla. He's changed his mind.
Thank you. If you put up one of your slides, any one that's really complicated, we can look at it, and I can suggest that you've taken a very simple chip thing, which is a commodity, and turned it from a good to a service. And yes, the complexity of that service has increased by an order of magnitude.
Yes.
And I can suggest the cost might have increased by an order of magnitude.
That's right.
What is the business model
yes,
that allows you to go to the automobile manufacturers and say, you're now going to pay 10 times as much for these commodity chips? How are you going to get them to do that in a very, very competitive industry where they're dealing with a $1 part and they want it at 90 cents and they don't want it at $10?
It's even worse with the PC OEMs. So if you talk to guys like Intel, not Intel, Dell or HP, they bicker and moan about a 20-cent component. Okay, the penny, when you say, you know what the word penny pinching means, it literally means that. They scrape every penny in order to make, you know, some kind of a margin on a laptop. And so when you move to a service model like that, the question is, could a bunch of these vendors who produce similar products in fact get together and share resources and share endorsement structures, right? Because for them, this is a cost, right? They got to keep track of the documentation, they have to sign stuff, they have to manage keys. Could they get together? And some are thinking of get together, not in the automotive sector, but in the PC OEM sector. Right, so this is one way to do that. Now, the other thing I should mention is that executive order is a stick. It's not a carrot, right? This is the government using a stick. And I've seen this before, the TPM chip that I worked on way back when. People like, nobody's wanting this, nobody's buying this. It's costing $2, and HP and Dell are not going to pay $2 for this chip. It's amazing stuff, but... And then in 2006, the US Army issued an announcement saying, henceforth, every PC computer that we purchase must have this chip. And it was unbelievable. Within 6 months, everybody had this chip. Lenovo was still part of IBM, had that chip. Dell, of course, had it. HP had it. Compaq had it. And a whole bunch of, even Asus, the Taiwanese company, they were late, but they had it, right? So the stick works to a limit, and sometimes it's needed to make certain disruptions, waking up people, the industry, then they change, and we're on a different trajectory, at least from that point of disruption.
We also know from the experience of the 1990s that the big infrastructure called SSL introduced a lot of costs, and it never really worked. It didn't really change the marketplace. So
I beg to differ.
Well, it is a very arguable point, and we can have that afterwards. But my point here is you created a huge infrastructure. Have you solved a problem of security, or have you moved it from the left to the right?
So what you mean is actually the PKI for the SSL. The SSL is the
whole industrial structure.
So the quick answer is, I think SSL has made its money back because all you guys, all of us, when we do shopping on Amazon, or wherever we buy, there's an SSL connection. So the SSL is probably one of the most, after the DNS infrastructure, it's probably the most used piece of protocol that people don't know about. It's the lock on your browser. When you know, and there's a lock, that's SSL running. It's everywhere. It's billions of hits per day. So I think that's a good piece of software. But what he's really talking about is the keys that go at the other endpoints. On the client side, on the consumer side, there's no keys. On the server side, you're lucky if they have some kind of an SSL certificate that has a public key. That's the problem, right? That there are no keys. But anyway, I think...
Maybe take it offline.
Yeah, we could take it offline.